going to let our little ones in.
Hi, Sam. Welcome back. Nice to have you with us again. I think you're the only one so far.
And Ria Betwe as well.
Is Ria Betwe also here? Hello, Ria Betwe.
Yes.
Welcome back. Oh, yes, there's Ria Betwe. Okay, so you guys can start looking at the do now in the meantime and see if you can maybe start on the first question and just see how far you get. We're just waiting for all the others to arrive and to join us. Okay, so there's Nawazi. Hello, Nawazi. How are you? Nice to have you with us again. This is our last lesson on geometry, isn't it? Anyway, get started on the do now, Nawazi, and then we'll go through it once everybody's had an opportunity to have a look. Don't know where everybody is today. There only seems to be the four of us so far. Ah, there's Harry. Hello, Harry. Welcome back. Nice to have you with us. Please get started on the do now. Welcome, Ayanda. Nice to have you with us again. We're just waiting a couple of minutes for everybody to arrive. There's a do now on the screen. So I encourage you to get started on that in the meantime, and then we'll get underway with our lesson in just a little bit. For some reason, we don't seem to have a very full house today. So I'll just wait one more minute. Hopefully you guys are trying the do now, and you've got your calculators and your books with you, and then we can get going. Okay, and I see Megan's joined us, and Sihle joined us, and Musa's joined us. Welcome, everybody. The do now is on the screen in front of us, but I'm going to get started with it now. Hopefully those of you that joined a few minutes ago have already maybe been able to work out the size of angle N. Otherwise, if you haven't, that's also okay. We're going to go through this now together. All right, this is our last lesson on geometry. And then from the next time we get together, it's all going to be exam prep. Okay, so if you have got ideas and questions and things that you want to talk about, you're welcome to email me. I did put out my email address the last time, and I'll just put it on the chat again for everybody. So Lee at, somebody has emailed me already. I haven't responded yet, but that's my email address, lee@watobe.com. So if you do see any questions that you don't know how to do and you want to discuss them, then please, I encourage you to send them to me, and then we can use them in our lesson, and we can share that and talk about it and discuss it. Okay. All right. So what we've been given is a parallelogram, right? So straight away, when they tell us that KLMN is a parallelogram, it means that it has all the qualities that a parallelogram possesses, right? So some of those qualities include the following things, right? So in other words, it's got two pairs of opposite sides that are parallel. So line KL is parallel to line NM. What else can I say about line KL and line NM other than that they are parallel? They are also
the same length.
They're also the same length, absolutely. So they're also equal in length. Good. All right. So KL and NM are parallel and they are equal to one another. Okay, so I think what I'll do is I'll leave off that little, because we've got another little line over here, right? But the whole line NM is equal to the whole line KL. And it's exactly the same with the other two sides as well. All right, so I can say that line NK is parallel to line ML, and line NK is also equal in length to line ML. What can I say about the whole of angle L and the whole of angle N? What's the story with them? Anybody know? What can I say about angle N and angle L?
Opposite
They're the
angle.
same.
So yes, they're opposite angles of a parallelogram, and that means that they are
Equal.
equal. Indeed, Megan. Okay, so opposite angles of a parallelogram are equal to one another. Okay, so L1 plus L2 is the same as N. K1 plus K2 is the same as M. Right, we don't have any diagonals in this case, but I mean, if we did, we could talk about the diagonals. But for now, that's about the most information that we can really say. They've also given us a little bit more. They've said to us that Kn equals Kq. So Kn is this side over here, and it equals Kq. Now, immediately, when they tell us that, so they're saying that to us, what do we interpret? What does that mean for us? If they say to us Kn equals Kq, what are they really saying? Anybody know?
It's equals to each other.
What's equal to each other, Sam?
Kn and Kq.
Yes, indeed, indeed. And the fact that they are equal to one another means what else? Do you know that it means something else?
It all equals to 180.
Good effort, but unfortunately, well done, but unfortunately not. Does anybody, Namusa's got her hand up. Namusa? Ah, and Tando, now you're on the right track here. Namusa, what were you going to say? And David's got a hand up. You can answer, Namusa. And Nosis has got a hand up. Okay, David, do you want to talk? Can unmute yourself? Go for
Yes,
it.
ma'am. What I wanted to say is that they are congruent to each other.
What's congruent to each other, David? Okay, so unfortunately, thanks, David, but unfortunately, congruent is not the word that I was looking for in this case. Okay, Nasisa, what did you want to say? You can unmute yourself, Nasisa.
Doesn't because the KQN is a triangle itself, and KN and KQ are equal. Doesn't make it an isosceles triangle in the parallelogram.
It does, Nasisa, quite right. Okay, that's exactly what I wanted you to see. Okay, so KNQ is an isosceles triangle. Okay, because KN is equal to KQ, right? And this is where, I don't know if the rest of you can see in the chat, Ntando has said their angles are equal. Yes, now Ntando, I just wish you had told me which angles were equal. I don't know if you are happy to unmute and talk, or if you want to put it in the chat, which angles are equal in triangle KNQ. Okay, so Ntando says that K, N, and Q are all equal to one another. Okay, now, unfortunately, that is not true, Ntando. You're very, very close, but unfortunately, that's not true, because if all three angles are equal to one another, then it's not isosceles anymore. It's then an equilateral or an equiangular triangle. Okay. N and Q, says Ria Betswe. There we go. All right, good. Ria Betswe, you've said the correct thing. All right, so angle N, which is this little angle down here, and angle Q1 are equal to one another. What's the reason, Ria Betswe? If I wanted to write down over here that angle N equals angle Q1, and I wanted to provide a reason for my answer, what would my reason be, Ria Betswe? Do you know?
Can I give it a go, Teacher Lee?
Please do.
I may be cheating because I'm not actually supposed to, but since QK and NK are equal in size, wouldn't it not have something to do with base angles?
Yes, but we're not allowed to use the words base angles. The department, it's okay. A lot of people do, and it's one of the old reasons, and they don't accept that anymore in the CAPS syllabus. So as far as CAPS is concerned, we have to say angles opposite equal sides. And it's actually something that is so easy that maybe it's difficult. All right. So what I'm going to do, but thanks, you're on the right track. Okay. So before we carry on any further, all right. So this is critical information for you. All right. We get different types of triangles, right? And when we say that a triangle is isosceles, it specifically means that there are two sides that are equal in length. Okay, so it can be a right angle can also be isosceles. So I'm drawing very badly here, but if that's a right angle over there, this side over here can be equal to this side over there, and I can get an isosceles right angle triangle. Okay, so triangles are very, very interesting shapes. Triangles are interesting because there is a relationship between the length of a side and the angle opposite that side. Okay, and we've seen that when we've done trigonometry, all right, and you're going to see it in more detail next year when you do trigonometry of triangles that are not right angled. So if I say that this side over here and that side over there are equal in length, the angles opposite those sides, so opposite this side over here, grade 10s, is this angle. This angle here is opposite this side. Opposite this side is that angle over there. That's what we mean in maths by opposite. Okay, so it doesn't matter how the isosceles triangle has been drawn. The orientation of it is unimportant, all right? What we need to do is we need to establish which two sides are equal. So if I draw my isosceles triangle facing that way, and it's this side over here and this side over here that are equal, this is called ABC. All right, the sides opposite the equal angles. So again, opposite side CA is angle B. Opposite side AB is angle C. So angle B equals angle C. Reason, angles opposite equal sides. We don't use the word base angles. We don't use the word isosceles. The Department of Education and the CAP syllabus tell us that we have to use these words, angles opposite equal sides. And you can't muddle up the order. You can't put opposite before you write the word angles. It's got to be exactly like that. Okay, so they are very particular. So let's just try this. What I'm going to do before we go back and we talk about it, I'm just going to draw a couple of isosceles triangles up here, and then we're going to ask some questions. All right, so let's call that KLM. Let's draw another one. Let's call that PQR. Let's draw another one. Let's call that XYZ. Okay, so now I'm going to ask you guys. All right, let's see. I am going to ask. Okay, Nizole. Right, look at triangle XYZ, the red triangle. And Nizole, I want you to tell me, either in the chat or unmute your mic, which two angles are equal in triangle XYZ. Okay, so Nizole says XZ equals YZ. Yes, those are the two sides that are equal. Now, which angles are equal, Nizole? Because of those sides being equal. Quite right. But now tell me the angles that are equal. It's okay, Maya. Well done. Okay, I'm glad you're here. Nizole, perfect. Can everybody see what Nizole's put in the chat? Okay, so angle X is equal to angle Y. Good. All right, they are the angles opposite the equal sides. Okay, so therefore, X equals Y. Reason, angles opposite equal sides. I hope you're all saying that out loud to yourselves at home as well. Let's have a look at another one. Okay, Harry, do this for us. Triangle KLM. Which angles are equal, Harry, in triangle KLM? C and M. Okay, does it look like a C? Okay, sorry, that's supposed to be an L. I beg your pardon. But you're quite right. Harry is correct. Okay, he's talking about this angle over here and that angle over there. The angles opposite the equal sides. All right, so here in this triangle, angle M equals angle L. Reason, say it to yourself. The more you say it, the more familiar you'll become with it. Angles opposite equal sides. Okay, last one. All right, and then we can move on. I'm going to ask Ntando. Ntando, in triangle POR, which two angles are equal? In POR, which two angles are equal? Ntando? Ntando says R and O. Good, Ntando, 100%. Okay, well done. All right, so the angles opposite the equal sides. The angles opposite the equal sides. Good. All right, so I will write angle R equals angle O. Reason, angles opposite equal sides. This is super important for you for geometry going forward. Okay, angles opposite equal sides is something that comes up grade 10, grade 11, and grade 12. So it's very important that we know this. Often very overlooked, small little reason, but very important for us. Okay, so hopefully now you're feeling a little bit more confident with finding the angles opposite equal sides. So now let's go back and go and put this into context with our question. All right, so they've told us that side Kn equals side Q1. So that means that N and Q1 are equal to one another because of angles opposite equal sides. Fine. But we don't know the size of angle Q1. All right. So they want us to work out angle N, but we also can see that angle N is going to be the same as angle. We spoke about this just before we started on the next question. The same as angle. Who knows?
L.
Angle L. When you say angle L, yes, 100%, that's right, okay, because they are opposite angles of a parallelogram. Okay, Harry says Q1. So yes, so N equals Q1 because of angles opposite equal sides. N equals L because they are opposite angles of a parallelogram. Okay, and then because N and Q1 are equal and N and L are equal, that means that Q1 and L are also going to be equal to each other, which we may use, but they want us to work out the size of N. What's missing? Which angle do we need to calculate to help us find the size of angle N? What's going to help us in this case? All we know is that this angle over here is 25. So look at this triangle. L1, absolutely, Megan. If we know how big L1 is, we know how big N is. Great. I agree with you. All right. So how are we going to work out L1? Look at L1 and try and find a relationship between L1 and another angle. What does L1 equal? What angle in this diagram does L1 equal?
25.
Which one, Sam?
25, ma'am. Is 25 meant for the side?
Yes, so 25 is L2, all right?
Okay.
Okay, so in this particular case, I want you to notice something else, okay? So Megan says, does it equal L2? Yes, it's going to, all right, but why, Megan? Why?
Ma'am, because the angle is split in half.
Yeah, it is, but you were not told that. Okay, you were not told in this information over here that this line QL cuts that angle in half. Okay, so unfortunately you are right, but you are making an assumption. Okay, and that's something that's very dangerous for us to do in maths, because if we make assumptions and we work on the wrong assumption, then it can lead us into trouble. There is a specific reason why angle L1 and angle L2 are equal one another. Okay, what does Nzole say in the chat? Ah, there we go. There we go. Look at what Nzole's put on, everybody. Nzole says angle Q3 equals 25 degrees. Angles opposite equal sides. Good. All right, can you see? Yeah, there we go. Good, Nzole, 100%. I don't know if the rest of you are following, but Nzole is looking at triangle LQM. Just like we were looking at all those triangles on the side over there. Can you see, grade 10s, side QM equals side ML? So which two angles are equal, grade 10s, in triangle LQM? Angle? It's an isosceles triangle. Which two angles are equal?
Q and L.
So L2 and
Oh, yes, ma'am.
Q3.
Q3.
Q3 and L2. Can the rest of you
Yes,
see that?
ma'am.
Well done, Sam. Thank you. All right, so Q3 and L2 are equal to one another. They are angles opposite equal sides. Okay, so can you see how now it's been placed in this diagram? All right, so that's going to be the first thing that we want to write. Okay, so we are going to say that angle Q3, so in question 1.1, we are going to say that angle Q3 equals 25 degrees. Angles opposite equal sides. Good. Now that we know that this angle over here and that angle over there are equal, what does Q3 equal? All right, so remember, this is a parallelogram. So if there are any lines that are slanted like this, it's possible for us to have what sort of angles? What sort of angles am I sort of trying to show you now? Shouldn't we name the triangle? Harry, you don't need to name the triangle when you are you're working with angles opposite equal sides. So you only name triangles when you are proving congruency and when you are proving similarity. Okay, then you need to name the triangles. All right, but not in a situation like this. If you want to, you can, but you're not going to get any marks for it. It's not a requirement as such. All right, so can everybody see that Nzole had also put in here that angle Q3, there we go, alternating. Okay, Maya, so which two angles are equal because of alternate angles, Maya? What are they called in this case?
Q3 and L1.
Beautiful, beautiful. Okay, so L1 equals 25 degrees. Alternate angles. All right, and that is because KL is parallel to NM. Good. All right, so now we know that that's 25. How big is N? Can we work out what N is now? Now that we know, because remember we said in the beginning, the whole of angle L equals the whole of angle N. What was the reason for that? Why do you want to add that? Yes, add the angles together. Yes, Megan. Okay, so add 25 and 25 together. Quite right. Yes, Nzole. Yes, Harry. Good. All right. So you're going to add 25 to 25, and that makes N equal to 50. Okay, what's my reason?
Ma'am, I'm lost.
Sam, are you lost?
Yo, I'm lost, ma'am.
Oh, I'm so sorry,
Because,
Sam.
ma'am, we've got 3 25s, right? Because Q3 is 25, L2 is 25, and L1 is also 25, right?
Yes.
But now how come we adding 2 of the 25s to get 50? Why don't we add all 3?
Okay, because let me just show you. That's fine, no problem. Okay. Sam, and you know what, there's probably other people that are, I'm so pleased. I'm so glad that you don't mind asking me. All right, Sam, this angle over here, L1 plus L2, is N. Okay, so N is L1 plus L2. Because they are opposite sides, you used a different method and still got the same answer, no problem, Nolwazi. You can share your method with us now. Because they are opposite angles of a parallelogram, and opposite angles of a parallelogram are equal. So what we did, Sam, is we first of all worked in triangle LQM, and we identified angle Q3 as also being 25 degrees. Then we said, well, because this is alternate to L1, that means that L1 is now 25 degrees. And it's this 25 here and this 25 here that have been added together to give us N. Does that make sense, Sam?
Yes, ma'am. Thank you so much.
All right, that's where it comes from. So we're not adding all three angles together. It's only two of the 25s that are equal to the N, not all three of them. Okay.
Okay, thank you, ma'am.
All right, so we worked out that this one was 25. We worked out that that one was, well, we were given that that one was 25, and that's where the 50 comes from. Okay. All right, so I'm glad you understand that a little bit better. How's everybody feeling? Is this making sense? Are you feeling good? How do you feel? You can give me some emojis. Yes. Thanks, Karabo. Okay, thanks, Megan. Good. Thanks, Ria Betsy. That's such a lovely smile. Maya, thanks. Okay, so yeah, please don't be afraid to stop me. Yes.
So does this, if N is 50, does this mean that Q1 is also 50 and K1 is also 50?
Ah, okay, but not K1. Not K1. Okay, but Sam, you are 100% correct. 100% correct. Okay, so now you are starting to make deductions. All right, so if we know that N is 50, we now know that Q1 is 50. Is triangle KNQ an equiangular triangle, Sam? What sort of triangle is it?
It's, yes, ma'am, what you said, ma'am. I know it's not an isosceles, but then it's an equi something.
Why is it not, but why is it not isosceles, Sam?
Because, ma'am, every side is, well, every angle is equal, I think. Angles are equal.
Which two sides are equal?
N and Q.
Okay, so KN and KQ are equal to one another.
Yes,
okay.
ma'am.
In Q, they haven't told us that it's the same length as the other two sides. Can you see that now when you look at it?
Yes, ma'am.
Okay, so in other words, they've told us that it is also an isosceles triangle. Okay, can you see that, everybody else as well? Can you see KN equals KQ? So here are the angles opposite equal sides. Okay, there are the sides that are equal. So yes, N and Q are the same size. So in question 1.2, they want us to work out the angles inside of KLQ. So in other words, this means that we need to work out the size of angle K2. We need to work out the size of angle Q2. And we need to work out the size of angle L1. Those are the three angles on the inside. Okay, so if I know that Q1 is 50, what would be my reason? Why would I say that Q1 is equal to 50? Can someone tell me?
Those opposite equal sides.
There we go. Well done, Harry. Sorry, Sam, and you also unmuted your mic. What were you going to say, Sam?
Ma'am, what Harry said.
Okay, all right, good. So angles opposite equal sides. Okay, so now Nzoli says you got K equal to 130. Nzoli, I assume you mean the whole of K. But hang on a second, all right? Okay, you mean the whole thing, okay. Just like we had noticed that there were alternate angles over here, what do you notice about angle Q1 and angle K2? What sort of angles are they?
Mine is an alternating angles.
Yes, they're also alternate angles. Okay, and alternate angles are? They're equal. Okay, alternate angles are equal. So if Q1 is alternate to K2, then it means that K2 is also equal to 50 because of alternate angles, because KL is parallel to NM. Okay, so now we know that this little angle over here is 50. They wanted us to discover the size of angle Q2 as well and angle L1. So we've done that. We've got K2. We can cross that off our list. How are we going to get angle Q2? What reason are we going to use? Remember, look at all the things that we already know. Okay, we know Q3. Nolwazi, good. Okay, so look in the chat, everybody. Look at what Nolwazi has suggested. Angle Q1 plus Q2 plus Q3 equals 180 degrees. Yes, Nolwazi, exactly, 100%. Okay, so we are going to make a statement about that. Okay, so Nolwazi, how big was Q1?
50?
It was. Good job. So angle Q1, Q2, and Q3 add up to 180 degrees because they are adjacent angles. That's it. Good, Nolwazi. On a straight line. Yes, Harry. Okay, now Nolwazi says Q1 is 50 and she's 100% correct. Okay. Q2 is what we want to find out, so we're going to leave that as Q2. Who knows how big Q3 is? How big is Q3?
25.
25, indeed, Sam. Okay, so we're going to substitute here. 25 equals 180. And now that Q2 is the only unknown in the equation, we can then work out how big it is. Okay, so that means we're going to have to subtract 75 from 180. So what does that leave us with? 105? All right.
Yes, ma'am.
Okay. All right. So now I think Nzole said that. Nzole, L was 50. Okay, well, we didn't get there. Q2 was 105, okay. And then for K, you got 130, but maybe that's the whole of K. Nzole, there's something that you've done here that I actually want to discuss with everybody else. But I'm going to just finish the question first, and then we can talk about it in relation to this particular picture. All right, so now we've got Q2, right? So we can cross that off our list. How then, grade 10s, are we going to work out the size of angle L1? What are we going to do? We've got K2, we've got Q2. How are we going to work out L1? What reason are we going to use or can we use?
We can say K2 plus Q2 plus L1 equals to 180.
Lovely, Nolwazi, and your reason for that?
Interior angles of a triangle.
Good, perfect. Okay, well done, 100%. Okay, so just as Nolwazi said, we can now say that L1 plus Q2 plus K2 adds up to 180 because they are interior angles of a triangle, so angle sum in triangle. All right, and we know that L1, let's just move this up, is what we want to find out. How big is Q2? Q2 is 105, so we can substitute that in. How big is K2? K2 was 50. So now we're going to pop that in, is equal to 180. Okay, so can someone, oh yeah, didn't we already find L1? Oh yeah, I'm being silly. There we go. We already knew what L1. Yeah. Quite right, Harry. It wouldn't be necessary for us to do this. Sorry. 100%. Okay, no reason for us to go and find something again when we already know what it is. So we could just say angle L1 angle L1 is 25 degrees, and that was calculated in 1.1. Yeah, thanks, Harry. I was asleep here. Okay, perfect. But if we didn't know what it was, then yes, using angles of a triangle would have been the perfect way to get it. Okay, how do you guys feel now? Is it making sense? Do you feel a little bit more confident? Is it good?
Ma'am, can we please do more examples?
You want to do more like this?
Yes, please.
Okay. Now, I hadn't actually prepared a whole lot of things because what we wanted to do was actually prove that a quad is a parallelogram. But I think this is obviously where you guys feel that you need practice. Okay, so let me go and have a look and see what else I've got. But there's just a conversation that I want to have with you before I go and do that. Still feeling good. I'm so glad, Nolwazi. Now, another mistake that students make when they are talking about geometry is this. Okay, so I just want to go over a few things. Okay. And if I'm telling you this again and you already know, then my apologies, but I think what I'm trying to emphasize here is really, really important for you for geometry going forward, okay? So if I want to talk about L on its own wearing a hat is the way that I would write an angle, okay? If I want to talk about a side has to be named with two capital letters next to one another, okay? That's how you would write a side. I can also name angles from the start to where the angle is to where it ends. So in other words, if I want to talk about this entire angle here, I can call it KLM. Or I can call it MLK. It doesn't matter. So if I go KLM like that, I mean this whole angle here. But now, if I say angle L, I mean the whole thing. But if I'm specifically talking about angle L1, I cannot call it L. All right, I have to be specific. Right, so if I mean angle L1, I either have to write angle L1, or if I want to name it according to this kind of naming, I have to call it angle KLQ or QLK. Okay, so in geometry, you have to be very, very specific. Right, if there is more than one angle at a particular point, and you're talking about the one but not the other, you can't just refer to it. So here at K, there are two angles. So I can't call K1 K. If I mean K1, I need to say K1. The only other thing that I could refer to K1 as is NKQ. Or if I wanted, QKN. If I mean specifically this angle over here at K2, all right, I can't just call it K. I've got to write K2, or I've got to write LKQ or QKL. All right, so remember that going forward. Okay, it's very, very important. Here, if I write angle N, there are no other angles at N. So the only angle I can possibly be referring to is that one. All right, but if I wanted to, I could call it angle KNQ or KNM. But because there are no other angles there, I can just call it angle K, angle N. And it's the same thing with M over here. There are no other angles, so it's by itself. So I can just refer to it as M. Does that make sense to everybody? How do you feel? Yes. Okay. So these are the sort of little things I think that sometimes we as teachers forget to tell our students, but it's really important for you in terms of your working and when you write things down, etc., etc. Okay. So if we go back up here and we have a look at what Nzoli said to us, Nzoli said, I got K equals 130. So when Nzoli says that, all right, this is what it means. She means that it's this entire angle over here that would be equal to 130. Okay, but if Nzoli meant specifically K2, then she can't call it K, all right? L is 50, so that means this entire angle over here is equal to 50. Okay, Nzoli, as it turns out, you are right because these are co-interior angles, so this whole thing would be equal to 130, and Q is equal to 105. But now hang on a second. Look here, Q is 105, but we've got Q1, Q2, or Q3. So we can't say Q because if we say Q, we mean everything that's at Q. Okay, so Nzoli must say Q3 or Q2 or Q1. Just see there was a new. Ma'am, I missed the whole explanation. My Wi-Fi switched off. Oh, shame. Oh, no. I'm happy to go through it again if you want me to. Let's just see how everybody else feels. So the things that I've just said now about naming, how you name angles, how you name sides. Nawazi says you got the answer of K using a whole different method. So what did you do, Nawazi? How did you do this question? How did you get K?
I got the answer of M first.
Of M first. Okay, and what did you get M to be?
I got M to be 130, and then I got opposite angles of a parallelogram. So
100%.
Yeah, that's how I did it.
That's fine. There's absolutely nothing wrong with that. So nothing wrong with that method at all. So you would have said that M is equal to 130 because there are co-interior angles because KL is parallel to NM. And then you could say that the whole of angle K is equal to 130 as well. And if we already know how big K1 is, we can subtract K1 from the whole of K to get K2. Okay, so nothing wrong with that at all. Okay. As long as what you are writing is true and you are substantiating your statement with the correct reason, you will get the marks. That's the thing with geometry is there's so many ways to say the same thing. Okay. All right. Let's just see. This is not really what I wanted us to do this lesson. I was actually hoping that we were going to spend more time talking about proving a quad as a palm, which is what that is. But I don't know if it's worth us starting that now. Let me just see what else we've got here.
You know what, Lee?
Yeah.
I reckon a lot of these questions, especially the ones that you guys would really like her to tackle, we can flag those and get through those in the Q&A or in the exam prep. I think that would be a lot better.
Okay, all right,
So
and
you
rather
guys,
just
we don't feel so pressured about time. So just focus more on what we need to focus on.
Okay, all right. So Namusa says, can we say that angle Q1, QT, supplementary? Yes, absolutely. Absolutely, Namusa. Okay, the word supplementary means adds up to 180 degrees. So yes, if you said that they were supplementary angles, that's correct. But there are more than see, the word supplementary means adds up to 180 degrees, but it's not just adjacent angles on a straight line that are supplementary. So if you were talking about angles that are supplementary, we can think of a few, all right? So angles that are supplementary, the first kind would be adjacent angles on a straight line. Other angles that are supplementary would be the angles, the interior angles of a triangle. What other angles are supplementary that you know about now, grade 10s? There's another, what else is supplementary? Exactly, Harry, well done. Co-interior angles. Okay, are also supplementary. Okay, so in this situation here, Namusa, I think that if you said, I suppose it would depend really on how strict your teacher is, but I would probably guess with no, even though you've said that that's true. I would go with adjacent angles on a straight line rather. Okay, because there are many different, as you've just seen here, there are a few different things that are supplementary. Right. So it's actually important to learn that angles that are supplementary, and then to learn angles that are equal. Okay, in fact, make a table for yourself. So angles that are equal okay, so can you think from grade 8, what angles do you know are equal to one another?
Square. Wait, no. I thought you said shape, sorry.
No, it's okay. So in other words, the kinds of angles that we've learned about since grade 8. So let's just see, there's a new message. Equilateral angles in a triangle, sure. Okay, so in an equilateral triangle, angles would be equal to one another, 100%. What I was sort of thinking was more like this, okay? So I'll do the first one, vertically opposite angles. Okay, Harry says alternate angles. I always do that wrong. Alternate angles. Nizole says corresponding angles. Good. Okay. What other angles do we know are equal to one another? We've got vertically opposite, we've got alternate angles, we've got corresponding angles. So you mentioned a shape earlier. Sam, we can come back to that. What about angles opposite equal sides? Okay, angles opposite equal sides are also equal to one another, aren't they? What else can we think of? Okay, so in a rhombus, the diagonals bisect the corner angles. So the corner angles of a rhombus are also equal. So in other words, if we've got a rhombus like this, I've drawn that so badly. So this angle over here and this angle over here will be equal. So will that one and so will that one. Opposite angles of a palm. There we go. You're getting into it. Yes, I know grade 8 and grade 9 wasn't great. I know you guys were stuck in lockdown. That angle there and that angle there and that angle there and that angle there. Okay, opposite angles of a palm. Excellent. Well done. Opposite angles of a palm are equal. Nice, Nizole. Well done. Okay, but hopefully this will help you. Okay, Nolwazi, it'll help you to understand which angles are equal and which angles are supplementary, and then this will just contribute to you being able to do maths or do geometry a little bit better. There's also in a square. So in a square, okay, so so the corner angles of a square, in a square specifically, okay, that's not a very good square. That looks more like a rectangle, but anyway. So here, those are all 90, aren't they? And in a square, not in anything else, but in a square, each of these will be equal to 45. Okay, so those are also angles that will be equal to one another. Okay, so the corner angles of a square will also be equal. Okay, so these are the things that we can think of so far. All right, and we need to know this in order to be able to carry on. All right, one last thing before we finish off for today. We've seen the word supplementary, okay? And we need to know that the word supplementary specifically means adds up to 180. In maths, we've got a word that we use when things add up to 90 degrees. What's that word? What's the word when things add up to 90 degrees? Yes, Namusa, right angle. There's another word that I'm looking for. No, Harry, bisect means to cut in half. Okay, so bisect means to cut in half. Okay. So angles can be bisected or lines can be bisected. Okay, bisect means to cut something in half. All right, so the word for adds up to 90 in maths is the word complementary. Okay, so complementary. So complementary, spelt like that. Okay, that means adds up to 90. All right, and it's different. So if I say to you, oh, Harry, you are a very good-looking young man, that's not the same compliment. Okay, if I'm saying something nice about you, that's compliment with an I. Okay, the maths compliment has got an E in the middle. Okay, so complementary. All right, so angles that are complementary add up to 90. Things that are bisected means that they are cut in half. It could be angles or it could be lines. The word supplementary means that things add up to 180. Supplementary angles that we know of, adjacent angles on a straight line, angles of a triangle, co-interior angles, angles that we know that are equal, vertically opposite, alternate angles, corresponding angles, angles opposite equal sides, the corner angles of a rhombus, the opposite angles of a parallelogram, and then also the corner angles of a square. Okay, so Coco, I know we said that we've both got load shedding and that we would need to finish off now. So I think I'm going to stop. I think I'm going to stop there, if that's okay.
Sure, no problem.
All right, and then we can definitely do more of those sort of type questions in our exam prep sessions.
Yes, I believe Euclidean geometry does come up, so we can do those. Yeah. And proving that a quadrilateral is a palm.
Yeah, is a palm. Yeah.
Excellent. Thank you so much, Lee. I'm just going to share my screen quickly. If I can find my presentation, please hold on. Oh, there it is. Okay. Well, well done, grade 10s, and thanks so much for asking as many questions as possible. That's actually quite helpful. Just give me 1 second. Oh, kind of missed that there. Okay, so this is where we are at the moment. We're actually completely done with geometry. Next week, we're going to be starting the exam prep lessons. Lee's going to be a teacher again, so yay for that. And yeah, this is the end of this, guys. Remember, if you have any questions for her regarding anything in your exams, please email her. I'm just going to pop your email into the chat again one more time.
No problem.
Just so everybody can remember, and you guys can jot it down. So if you have any questions, then you can send those through to her via email, and then we can deal with those when we get to that specific section in that one. All right. All right, so that is it from us, guys. Thank you so much for everything. We are almost there. Just a month and a half, I believe, and this is the end of it for you guys. And hopefully we'll see you guys again in grade 11. We have faith. We're going to see all of you guys again in grade 11. Thanks so much for joining us every single evening. We appreciate you guys being here. And yeah, we will see you guys all next week, Tuesday. All right. Thanks, guys.
Okay.
Bye-bye.
Take care. Bye, everybody.
Bye, ma'am.
Bye.
Bye. Have a good week. Or what's left of it anyway. No problem. Bye.